Welcome back, goblins. We are going to do our second lesson on factoring today. We're going to talk about grouping. Why am I changing my alphabets? Not alphabet. You feel what I mean, though. Let's change that to purple just like I like it. Let's make that skinny just like I like them. Nice W's. All right. We're going to talk about grouping today, which is a type of factoring. This, I think, is the easiest type of factoring you're going to learn. So you better enjoy today. You got to let it sit. You got a little marinate. Think of today as like a beautiful hot tub. And you get to just sit and soak in the sauna. You feel me? You're going to lose all anxiety. After today's lesson, you're going to be just chilling, super relaxed. So, let's go do it, shall we? All right. So, factoring by grouping is kind of like GCF factoring. In fact, we're going to do GCF factoring while grouping, but it's a little, all right, maybe I lied. Maybe it's not the easiest. GCF's the easiest, but this is second easiest because it's basically GCF. So, you've done this, right? We've factored out an x. We went, divide an x here, divide an x here. X goes in front. Oh, look, a 3 can come out too because 3 goes into 3 and 12. Divide, and you get x plus 4, right? What if, though, we had something like this? So, when we're doing GCF factoring, we ask ourselves, what's in common? So, if this, hang on, what's in... I tried to talk and write at the same time, and I can't do it. If we look at what these two things inhabit, we have a x minus 3 plus 6 x minus 3. What's the thing that's here that's also here? X minus 3, Mr. Barton. Oh my gosh, you're so smart. X minus 3. So what we're going to do is we're going to factor out x minus 3. So we're going to put the thing we're factoring out in front, and then we're going to divide both things by the thing we're factoring out. Okay, so let's take an aside and ask ourselves some questions. What's 4 divided by 4? Mr. Barton, that's so easy. It's 1. Duh. Okay. What about x squared divided by x squared? The x's cancel. Okay, but what's it equal? 1. All right, good job. So anything divided by itself cancels and is equal to 1. So what's x minus 3 divided by x minus 3? They cancel, and now it's a 1, but 1 times a is whatever. So when I divide by x minus 3, the x minus 3 goes away, and we're left with a. When I divide by x minus 3, the x minus 3 goes away, and we're left with plus 6. This is factored now. Okay. This is the gist of what you're going to do. We're going to have to do one extra step to get it to look like this so that we can factor out the x minus 3, but then you're just factoring out the thing they have in common, and it's not that hard. Okay? So let's practice on these just to get the feel for the easy step, then we'll throw in the hard step. What do these have in common? X minus 5. So we're going to put the x minus 5 in front, parentheses for what's left over, divide by x minus 5. The x minus 5s cancel, and we have 2 left. The x minus 5s cancel, and we have plus b left. Factored. Okay. If that was too fast, rewind it. Hit the left arrow on your keyboard like 4 or 5 times. Go back and re-watch this example. You ask what they have in common. You divide by that. Put the thing in common in front. Write what's left over in its own parentheses. Let's do a couple more examples. Let's do them purple, though. Purple's nicer to look at. What do they have in common? A plus 1. So we write the a plus 1 in front, put it in parentheses. What's left over, it goes in a second set of parentheses. So these cancel, z is left over. These cancel, minus y is left over, factored. One more. What do these have in common? 3 minus 4a. 3 minus 4a. So we put the 3 minus 4a in front. Parentheses. Cancel. What's left over? Cancel. What's left over? All right. There's an extra thing we have to look at here, though. What do these have in common? A y. So we can take a y out. Let's do it in blue. So the y will come out. I'm going to put the y all the way in the front, though. The reason for this is purely aesthetic. It doesn't really matter if it's all the way in front. This I just bring down. Divide by y. Divide by y. Y's cancel. X is left over. We had two y's. We divide by 1. It cancels one of them, and we have a y left over. So this one had to take out a GCF as an extra step there. Okay. And then that's factored. Okay, not too bad. Pretty easy, I think, so far. Okay, if you're puzzled right now, pause the video. Go back, re-watch this entire slide. If you're confused, it doesn't get easier for the rest of the video. It gets harder. So you need to pause, go back, let it simmer a little bit, and try and understand what you're doing, okay? Make sure you know what you're doing here. If you're still confused at the end of the video, even though you persisted and you rewatched it maybe once or twice, ask me for help, please. All right, let's go look at the full process. So for factoring by grouping, this method is used to factor polynomials that have pairs of terms with common factors. The real giveaway is that these have 4 terms. Okay, if we look at them, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. Anytime you have 4 terms in your factoring problem, it's factoring by grouping. Okay, here's the steps we're going to follow. Step 1. We're going to factor the first 2 terms and the last 2 terms separately. So we're going to have 1, 2, 3, 4 terms. We're going to look at them in little baby groups. We're going to look at the first 2 as a group and the second 2 as a group and factor those groups independent of each other. Yes, that's allowed. After we do this, we're going to divide out the GCF, which is what we just practiced on this slide, from the result. So we're going to take it out. Step 3 is regroup. That basically just means write your answer. Okay, it's not that bad. All right, let's go practice those steps. Let's look at these looking here. So we're going to look at the first 2 numbers as a group and the first 2 terms as a group. What do these 2 numbers have in common? X squared, right? We have 2 x's here and 3 here, so I can take out 2 x's. So put the thing you're factoring out in front, parentheses, divide. We had 3, we took out 2, there's 1 left. Plus, we had 2, we took it out. What's x squared divided by itself? Anything divided by itself is 1. So this is this thing, but factored. Okay. Now, we look at x plus 1. What do they have in common? Well, nothing. So what we're going to put, because they don't have anything in common, is just 1. So plus 1. And then if I divide by 1, x divided by 1 is x. 1 divided by 1 is 1. And that's factored. Okay. So now we look at these and we ask ourselves, what do they have in common? They have x plus 1 in common, so we're going to factor that out. put the x plus 1 in front, and then divide by x plus 1 on both of these. These cancel. What's left over? X squared. Divide. These cancel. What's left over? Plus 1. And then this is our answer. So x plus 1 times x squared plus 1. All right, let's look at another one, because this one was a little weird, and this plus 1 is not a normal thing. This one is a little bit more close to what we normally will be looking at. So again, we're going to look at the first two terms together, then the last two terms together. So what do these have in common? Well, 1 and 8 don't have any common factors. We do have x squared in common, though. So we're going to divide both of these by x squared. Put the GCF in front. Divide. So we had 3 x's. We took 2 out. There's 1 left. Plus, bring down the 8 because we're not doing anything with the number. X squared divided by x squared cancels. So we have x squared times x plus 8. Now, we do the same here. 6 goes into 6 and 48. So we're going to take out the GCF of 6. So we're going to put plus 6 because the 6 is positive. And then we're going to divide. These cancel, and we have just x. 6 goes into 48 8 times. Okay, let's take a sec to look at something and just point it out so you notice it. Do you see how these match? That should always happen. If you don't get something matching, you're not allowed to take it out, right? This step here is what matches, factor it out. If nothing matches, you goofed up and you did something wrong. So if these don't match, that's the time you stop, you go back, and you see what you did wrong. All right, now we ask ourselves, what matches x plus 8? So we're going to take the x plus 8, and we're going to take that out of both sides. So the GCF, the x plus 8, goes in front. Cancel. The leftover goes in its own set of parentheses. Cancel. The leftover goes in the set of parentheses. This is the answer. All right, we're going to do one more, and then we're going to look at, I think, ones with some GCFs. So we look at the first two terms and then the last two terms. We ask, what do these have in common? They have an x squared in common. So we're going to take out an x squared. All right. We had 3 x's. We took 2 out. We have 1 left. And we bring down our 3 because we didn't do anything with the number. Here, we had 2 x's. We took 2 out. They cancel. Bring down the plus 2. All right. This one, we don't have anything in common again, right? 3 and 2 don't have a number in common. They don't both have an x. So what we're going to do is we're going to put plus 1, and then we're going to put these in parentheses. 3x plus 2. And then notice 3x plus 2 matches 3x plus 2. The place this 1 comes from is we're saying we have 1 3x plus 2. That's what we're doing there. So now we take out the thing in common, 3x plus 2. Divide by 3x plus 2. This cancels. Put the leftover in the parentheses. This cancels. Put the leftover in the parentheses. And there's our answer. Alrighty, not too bad. Okay. Let me go ahead and scold my dog for whining. Crisis averted. She's not going to freak out. So we're going to look at these. They don't have any GCFs, but I'll show you a couple tricks that we can do on these. Maybe with this one. This one looks like a good candidate for a trick I know. So just 3 more examples just to really hammer home the point and make sure you know what you're doing. So we look at these first 2 terms and we ask, what do they have in common? Well, they both have a 4 and they both have some x's. They have 4 and 3 x's, so we can take 3 of them out. So we're going to divide this by 4x cubed. So we'll put that in front. 4 divided by 4 is 1. We had 4 x's. We took 3 out. There's 1 left. Negative 4 divided by 4 is negative 1. We had 3 x's. We took all 3 out, so there are none left. Okay. At this point, stop copying what I'm doing. I'm going to do something wrong really quick, and then I'm going to show you how to fix it. So now I'm going to do what I did before. We just have plus 1. Put this thing in parentheses because there's nothing in common. Negative x plus 1. Do you see how this doesn't match this? This is x minus 1. This is negative x plus 1. This is positive. This is negative. This is negative. This is positive. So the signs are switched, and that's not good. So the way we get the signs to match, now you're going to pick up your pencil again, and you're going to follow along because I'm going to do it correctly. We recognize that this is going to have the wrong signs, so we need to take out a negative to switch them so that it will match with this when we're done. So we're going to divide by a negative 1. So we're going to put minus 1, because that's the GCF we're dividing by. Negative 1 divided by negative 1 is 1, bring down our x. 1 divided by negative 1 is negative 1. Now this matches this like we want it to. So sometimes you're going to have to divide by a negative to change some signs. All right. Now, the thing that these have in common is the 1x minus 1. So we're going to take that out. X minus 1. This will cancel. We have 4x cubed left. This will go away. We have minus 1 left. And then this is factored. All right, let's look at this one. This one is a good one for a trick that I know. You can rearrange these if you think it'll make your life easier. So what we're going to do is I'm going to say, oh, this one and this one have a 4. So I'm going to switch these terms to get the x's together and to get the 4's together. So I'm going to have x cubed, move this one in front, minus x, plus 4x squared, minus 4. All right. Now, we can do the same grouping stuff. What do these first two have in common? They both have an x. So we had 3 x's. We took 1 out. There's 2 left. We had minus x divided by x is 1. Here, these both have a 4 in common. So we're going to divide by 4. Put your GCF in front, parentheses. 4 goes into 4 one time, bring down the x squared. Negative 4 divided by 4 is negative 1. And look, these match. So now, we take out the matching term, x squared minus 1. And then we put the remainders, x plus 4, in their own set of parentheses. Technically, this can be factored a little more, but we're not going to worry about that too much because I think that's in a later lesson. All right, last one. This one, we could move the 3 here and group it, but it doesn't really matter. If I hadn't rearranged the order of this one, it would still work. You could take an x squared out of these and then a negative 1 out of these, and then it'll still work out the same way. So here, we'll just not rearrange it. So here, let's take out an x squared, because that's what they have in common. So we're going to put x squared, bring down our 3. We had 3 x's. We're taking 2 out, so there will be 1 left. X squared divided by x squared is 1. Here, there's nothing in common, and we don't need to switch the sign. So we're going to put plus 1 and then put this in parentheses. Now, we take out the thing that's in common, the 3x plus 1, and then we write their coefficients or the remainders together in their own set of parentheses. And that's factoring by grouping. Quick 20-minute video. Make sure you like and subscribe because you know how hard I work on these. You guys deserve the best, so I give you probably not the best, but pretty darn good videos, I like to think. If you have questions, make sure you go ask me. And as always, have a wonderful day. I'll see you next time.